Hey everyone, it's Colin. How's it going? A couple years ago, I tried to tackle a design flaw with my Sony mirrorless camera, but I wasn't exactly successful. Can I get it right the second time around? So here's the story. Sony's a5100 offers a lot of performance in a very small package. Very well might be the ultimate vlogging camera, except for one problem. It overheats and shuts down after just a few minutes of shooting video. In a previous episode, I tried to fix this, but after dealing with some setbacks, I was only able to improve things just a little bit. But this time, I had a plan and the parts to pull it off, and it all started with taking the camera apart. Underneath this small heatsink lies the camera's processor and RAM buffer. The first time I took the camera apart, there was only a thermal pad on the RAM chip. I added a pad to the processor and found that while it didn't fix the overheating, it did improve things. That led me to believe that the problem was just a matter of getting better thermal transfer from the chips to the outside casing. I decided that the silicone thermal pads simply weren't cutting it, so I picked up some copper shims in various thicknesses. They offer better thermal efficiency and therefore should do a better job interfacing the chips to the heatsink. I found a couple of shims that matched the thickness of the pads I removed, then just to cover all my bases, I applied some thermal paste to the chips. This isn't often done with plastic encapsulated chips like these, but I figured every advantage I could have, no matter how small, might be worth it. I made a little bit of a mess applying the paste, but I got it cleaned up with isopropyl alcohol. No big deal. I dropped the shims into place and put some more paste between them and the heatsink. Then I turned my attention to the camera's rear metal plate. There was a thin thermal pad where it pressed up against the heatsink, but considering it had bubbles in it, I suspected it wasn't making all that good contact. I had bought some new thermal pads in several sizes, so I picked one that looked just a bit thicker and cut it to the full size of the metal plate. I peeled off the old pad, applied the new one, then trimmed back this plastic bit that was getting in the way. At that point, I reassembled the camera. Everything went back together as it should, and when I put the battery and memory card back in, it powered on and worked just fine. I set the camera on the windowsill and started recording a video clip so I could test if the overheating was fixed. While setting up another camera to film the A5100 screen, I noticed that the low battery warning had popped up. This struck me as a little odd because when I first hit record, it said there was still something like 80% battery left, and it had only been a few minutes. But I figured I was using an older battery and went to grab another one. I turned the camera off, swapped the batteries out, and then things started going downhill very quickly. The camera powered on but failed to fully boot up. Live view worked, but only some of the icons were on the screen, and none of the buttons were responsive. What's more, when I went to switch the camera off, it just stayed on. I had to drop the battery out to actually turn it off. Turning it on again led to either the same behavior or just a blinking red LED on the bottom of the camera. I tried all sorts of hard reset procedures I found online. None of them helped. I resigned myself to taking the camera apart again and undoing the mods. Even though all I had done was replace some thermal pads, clearly something had gone very wrong. I pulled out the copper shims, cleaned up all the thermal paste, and put some new pads in there instead. And after reassembling it, again, it still didn't work. The same weird behavior as before. I wondered if it was maybe a bizarre software glitch, so I hooked the camera up to my laptop to reflash the firmware. The USB battery charging function worked and the camera went into storage mode just as it should, but the firmware tool just wasn't able to detect it. So I'm left at a loss as to what exactly the problem is. At first I suspected maybe the thermal paste was shorting a connection somewhere, but the paste I used is advertised as being not electrically conductive. I even tested this myself using a multimeter, which confirmed there was no continuity with both probes stuck into a blob of the paste. I wondered if I had somehow damaged a connection between a chip and the board. It never felt like any of the shims or replacement pads were applying too much pressure when I installed them, but these are ball grid array chips, and those can be touchy. Another thing I considered was the history of this particular camera. The last time I tried to fix the overheating, I ended up breaking the display ribbon cable connector. Ultimately, I picked up another used A5100 from eBay. It had a cracked screen from being dropped, but the rest of the camera was fine. I swapped my good screen over and the camera worked great for another couple of years, overheating aside. But maybe there was some lingering damage from when it got dropped that really only became an issue when I opened up the camera again. Obviously, I'm disappointed with this outcome. I really wanted to see if it was possible to fix this super frustrating design flaw. But the more I think about it, the more I realize it's just not worth pursuing anymore. Overheating is a chronic problem with Sony crop sensor mirrorless cameras in general, not just the A5100. The A6000 and 6300 have it just as bad, and while Sony added an option with the A6500 to address it, it's just a software tweak. It raises the temperature threshold before the camera shuts down, but that camera still ends up overheating, so the feature just delays the inevitable. And perhaps it was foolish of me to think that this problem could even be solved to begin with. I mean, if Sony's own engineers couldn't come up with a solution, why would some random YouTuber with a screwdriver set and a few bucks in parts be able to do any better? At the end of that previous episode, I hypothetically said I should just buy a camera that doesn't overheat. Well, I ended up taking my own advice. I moved over to the Micro Four Thirds platform and haven't looked back. And while I really liked the compact size and high quality footage I got from my A5100, it's just not the camera that I, or a lot of us, hoped it would be. And perhaps more importantly, I've come to the conclusion that given my success rate so far, maybe I'm better off just using cameras instead of taking them apart. If you liked the video, I'd appreciate a thumbs up. Be sure to subscribe if you haven't already. You can follow me on Twitter and Instagram at thisdoesnotcomp. And as always, thanks for watching.